are not adequately equipped to communicate well in technical language or in normal language regarding their background, regarding their introductions and things like that. So the whole thing has arisen because of your lack of communicating skills. So now you have a new subject and you are required to improve your communication skills. And we also have been given the responsibility of assessing your book review program. I think you have already received the details. It has to be a 500-page write-up, and you have to read or pick a book. I think the subject will be given to you, not yet. And by 20th June, we are supposed to get the result reports. And I think by 15th July, it has to be sent to Chennai, the results of that, 15th July. And 20th June, you're supposed to finish reading the book, writing the report, and uploading it. I don't have your batch boys in my group. I have got roll numbers from 8141 to 8170 of the 2017 entry batch, not yours. 8141 to 8170. That's how much? About 30 boys. So that's additional work for us. Anyway, how many boys are here? 33. They're still coming in. And we are already on record. Okay. Karthik, where were we in our last class?
The medium speed engines.
Yeah, which part? Which plate?
Advantages were done, sir, I remember last.
I didn't get you.
Sir, advantages were done
Oh,
at
advantage.
last.
Okay. Advantages. Okay. And in systems, there's advantages. Constructional details. Where is car? What page was it? Thin shell bearings. Have we done thin shell bearings?
No, sir.
No. Okay. Pistons. We have done pistons.
So it was much before.
Much before. Advantages. Yes, here you are. You are doing advantages. Okay, my God, you're still going backward. Okay, we are going to go pretty fast in this. Still advantages. Okay. Yeah, this is, and previous to this, oh my God, you've done nothing that means. Okay, desirable features. You have seen there are 9 desirable features. And thereafter, we started on medium speed engine advantages. Somebody has come to class. Ketan Kumar Sinha. See, this is what is a little bit of a disturbance. 33 only. So what are the advantages in a medium speed engines? I think it's quite clearly mentioned here. So we'll go through what has been written here. Indrajit Mitra. Okay, 936, no more. We are not admitting anymore. And that is all. Fellows come late in class and you keep reading, and I keep admitting, and you keep more and more in the same coming late sequence. There he is. Now, how do I proceed like this? Mrityunjay Das. Okay, this will be the last. No more. So we have 34 boys, and this is section C. Paran Abdus, are you there? Paran, are you there? Kundan Kumar, are you there? Not there. Neither of the class in charges are there. Okay, Karthik, you take charge. And I need to know the absentees at the end of the class. Okay.
Okay, sir.
What? Okay. So what are the advantages that we have in your medium speed engines? They are reduced in height and they give more space for cargo. Higher power to weight ratio, which means the engine is much lighter and you get to carry a bigger mass of cargo. Next is reduction gear enables ideal propeller RPM. See, the engine is chosen by the ship owner. He wants all those features that were listed earlier, but the propeller is based on the size of the ship, the shape of the ship, and the required RPM to propel the ship at the best economical advantage. So the size of the propeller is usually very large, and a large propeller cannot go at a high RPM. The larger the propeller, slower the RPM for a higher propeller efficiency. Now, I will not go into details of that. It goes into design of the blades. There are lots of design factors into it. But the propeller is going to rotate at a very slow speed. You have an engine which is going to run at 500 RPM, but the propeller needs to run at just 100 RPM. So after the engine and propeller is decided for the ship, next the shipbuilder has to choose a reduction gearbox which will suit the engine as well as the propeller. So it is a matching experience. So the shipbuilder will decide on the propeller on the reduction gear, and this enables the ideal propeller RPM. All right. So the gearbox is chosen based on engine and propeller performance and their requirements. So accordingly, you have a gearbox. Okay. Next is gearing allows the best propeller choice, obviously, and vice versa, both ways. There are so many gearboxes with so many ratios. You can pick and choose. In fact, you can have a gearbox made to order. So these things are also possible in today's world. Next is what are the modern trends of medium speed engines? These are having unidirectional geared diesel with reverse reduction gear. That means the engine, once it starts, it doesn't stop. It keeps running, and it keeps running in only one direction. And with that one direction rotation, you have a gearing system with a clutch system which will have a reduction gear. The gearing that is there, it will have a reversing facility. So the engine will keep running. You don't need to start and stop it. All you need to do is clutch and declutch it and give the reverse signal. That's all. So what happens? The biggest advantage is that you don't need to restart the engine. Once it is running, you are comfortable. But if you stop and start, stop and start, stop and start each time when you're maneuvering, then there is a bigger possibility of mishap. Your air consumption is also very high. Your compressors are also overloaded, things like that. We'll go more into it as we come back. Next is the modern trend is using controllable pitch propeller. I think all of you know what is a controllable pitch propeller. The angle of the blades can be changed, and the mechanism consists of a hydraulic unit inside the hub of the propeller and long rods which are hydraulically operated ultimately rotate a boss or rotate a eccentric, and that eccentric has got several points on which the blades are fitted, and the blades are capable of changing their angle, thereby changing their pitch. So this is why it is called a controllable pitch propeller. And if the engine continues to run and you want to stop the ship, all you need to do is put the blade in a neutral axis, which means the propeller will keep turning, but there will be no thrust ahead or astern. If you want astern movement, you will have to turn the angle of the blade to a certain direction. And if you want to give it ahead, you have to change the blade to the other direction. All that is done from the control room. So that is what is the controllable pitch propeller, and these are commonly used in your medium speed engines. Other than this, you have electric generator. Of course, all your auxiliary engines are all medium speed engines, and they produce electricity. Apart from this, your main engine, which may be a medium speed engine, may have multiple number of engines, maybe 5 engines, and each of them is generating electricity. And that electricity is used to propel the ship through a synchronous motor, which is directly running your propeller. These are called diesel electric ships. They are also very popular because they do not have much of issues regarding gearboxes and clutches and things like that. They are strictly electrically controlled. In fact, their economy has been found to be very substantial because you need not run all five engines to run your propeller. There are times when the ship is on ballast from one point to another. That time they don't need so much of power to rotate the propeller. So they will keep two engines on. And with two engines, one is adequate to supply power for the propeller, and one is adequate to supply your domestic requirements, your air conditioning or heating, lighting, etc. So these are really diesel electric ships, and we don't see them much on cargo vessels that we serve on. They will be mainly on passenger ships or naval ships. They are more common. We have more of the geared diesels. Then reverse reduction gearing and common pitch, controllable pitch propeller are most common. Some of them are having, reefer cargo. The reefer cargo, they are also very, very highly stressed ships. Reefer cargo ships and your um, product carriers. These are commonly using controllable pitch propellers. Okay. What are the benefits of having medium speed engines as your propulsion units? Okay. What are the benefits? One is less starting torque required, clutch is disengaged, or the CPP is in neutral position. Now, when you start the engine, let's consider a two-stroke engine. That two-stroke engine is directly coupled to to the propeller. So when you want to start the engine, you have to overcome the resistance of the engine itself, also overcome the resistance by the propeller. So the quantity of air required and the pressure of air required to push the piston down will be much more. All right. Now in the medium speed engine, you have a clutch mechanism. So all you need to do is declutch the propeller and your engine is free. So you need very little air to give a little push on the piston and the engine starts rotating. And it helps to start the engine with the minuscule quantity of air. So you don't need very large air bottles. You don't need high capacity compressors. So you save a lot of money in that. So that is why a medium speed engine has been found to be more advantageous. Other than this, in the case of controllable pitch propeller, you can put the propeller in neutral pitch and then there is no resistance to the engine where the propeller is concerned. So it is very easy to start that engine. In fact, I will tell you an experience. We had a two-stroke large bore engine, and anytime the rudder was hard on port, we could not start the engine. No matter how much air you give, you cannot. So this should give you an idea how much resistance a propeller is subject to. Moment that rudder was put to hard on port, we give air, it will run and then stop. It wouldn't pick up the momentum. Then we realized on the rudder angle indicator that the rudder is on hard on port. So we used to ring up the bridge and tell them, all right, put the rudder on midship. So they used to put it on midship and then the engine used to run. Why? Because when the propeller was turning, it was getting a lot of resistance, not being allowed to throw the water beyond the rudder because the rudder was acting almost like a wall. So the propeller was pushing water against it, and in turn, the rudder was under a lot of resistance. The propeller was under a lot of resistance. So the engine wouldn't pick up the speed for the momentum required to continue and start combustion. So the propeller provides a lot of resistance to the engine. So if you can disconnect it, then the engine is more easily started. Okay. Next, if you have a universally direction ship engine running, then the number of starts will be much reduced because the engine will continuously run. Even though the propeller has stopped, the engine keeps running. It is something like your car. When you press the clutch, you can keep the engine running, isn't it? Or you can put it on neutral, and the engine is running, but the car is stopped. Same principle is used on the ship. Okay. So the starting air capacity is reduced. On board the ship, you have very large air bottles. They can be put into much smaller bottles. Then compressor running time is also reduced. So that is one big advantage. The engines can be tested in port at full speed. Once you declutch the engine, you can run the engine at full speed. This is of enormous advantage as trials after overhaul, because after you decarbonize a unit, you have changed, let us say, a piston or piston rings or a bearing, and then you put the parts back, and you're not sure if the engine is going to run satisfactorily or not. And you can't afford to try it out because the engine is directly coupled to the propeller. And if you start the engine and run it, the whole ship will take off, will tear the mooring ropes also. So you cannot try out the engines in the case of a large bore two-stroke engine having direct propeller drive. But in the case of a medium speed engine, you have the option of disengaging the clutch and run the engine at full speed. You can run it for 1 hour, 2 hours, 3 hours, no problem. Then you check around that engine whether everything is satisfactory after your overhaul. Okay. Once it is certified that it is perfectly satisfactory, you can shut it off and go up and relax, because when the ship is required to go out of the harbor, you know fully sure that your engine is fully ready, no problems. That is what very big advantage is. Otherwise, what would happen? If you've done everything and then when it's time to depart from a harbor, you start the engine and the liner starts leaking, or the fuel oil pipe starts leaking, or something is making a noise which has not been tightened properly. So these problems come up very often after overhauling an engine. So you need to try out the engine. And this is possible only in the case of a medium speed engine which has a clutch arrangement. Okay. I hope you follow the understanding what I'm saying. Himanish Mukherjee, are you awake now? Still not awake. Himanish Mukherjee, where is he? He's there only on paper. Yes, sir. What's happened? Your microphone is not working. Yes, I can hear you. I can't hear you, sorry. I can only read the message that you're giving. I cannot hear you. I can hear Karthik, I can hear Manohar Singh. Can you hear me?
Yes, sir.
See, Manohar Singh can hear me, but Himanish Mukherjee something. Oh, I am having microphone issues. Okay, never mind. Stay awake. That's the important part. Okay, next is that's why. So you realize how important it is to try out an engine after you've done the overhaul, and this is possible with medium speed engines with the clutch disengaged. Apart from this, you have multiple uses in port with the clutch disengaged. That means the ship owner, he has paid money to buy a main engine with a lot of money. Now, if that is used only for transporting the ship, once it reaches the port, then it is sitting idle. That means it is not giving you the returns for your investment. So this medium speed engine, it can be used for multiple occasions when the clutch is disengaged. That means the propeller is not engaged with the engine. All right. So what are the uses it can have? Oh, it is used for power generation with heavy oil. Okay. Now, heavy oil is cheaper than diesel oil. So instead of having 3 auxiliary engines which are burning distillate fuel, you have only 2. So you save the cost of one and you save the cost of using diesel oil. And in port, that main engine which is burning heavy oil is directly running a generator which will provide you with the electricity required for your cargo operations, required for your air conditioning, required for your lighting, required for all your cooling water pumps, everything. So you burn heavy oil to produce the electricity. Otherwise, what you would have been doing is burning diesel oil, light distillate oil, which is much more costly to generate electricity. So this is one big use of the main engine, and it is being used with as a return for your investment that you're giving. It is also used for cargo pumps to discharge oil in tankers. Okay. The engine room is located with bulkheads at the forward and aft. So the engine is inside that engine room. Now, from the engine room, you have a shaft going to the propeller. You have a clutch system. This clutch can be disengaged to relieve the engine On the other side of the engine, you have a shaft which is protruding beyond the bulkhead. And then it goes to a room called the pump room. And this is directly connected to a pump, a very large pump. And that pump is used to transport the cargo from the ship to shore. So when the ship is reached harbor or unloading point, then you disengage the clutch and use the main engine to operate these very large pumps. And this large pump will help in pumping out the cargo to shore. So this is a secondary use. It can also be used to drive a generator to generate electricity. So as a main engine, it is giving full returns to the ship owner who has paid a lot of money. In the process, he has reduced the number of diesel engines he is using for auxiliary engines. Okay. I hope it is very clear. If you have any questions, not understanding, type it out on the chat column. Do not hesitate. Ask any question, even if it is a silly question. Don't worry. This is a class. It is a process of interchange of information, and it is not a test. Okay. Used for cargo pumps to discharge oil tankers. Yes, that is one of them. Other than this, what advantage does a medium speed engine have? It has improved maneuverability with pulse turbocharging. This improved maneuverability ultimately means how responsive the engine is when you give more fuel. A two-stroke engine is not so responsive. You give fuel, you have to wait till such time the turbocharger picks up speed, gives air to the engine burns that extra fuel that you have given, and then that comes out as power in the propeller. And in the meantime, in the two-stroke engine, when you give more fuel, instantaneously at that point, the quantity of fuel is more than the air that is supplied. So you will get a lot of black smoke in the funnel. So now that is becoming a bit of a restrictive issue overseas. You cannot discharge smoke just like that. Now, initially it was permitted during maneuvering, but now even during maneuvering, they are becoming more rigid. So in that instance, the medium speed engine, moment to give fuel, the turbocharger, which is using pulse turbocharging, instantaneously provides air to the engine, which in turn can burn the extra fuel to give the immediate power at your propeller. The moment you move the fuel lever, you get power at the propeller. So the captain has a better option of directing his ship in docking or undocking. So that is why it is called better maneuverability. If he wants to suddenly increase the speed, he can give on the medium speed engine. In a two-stroke engine, it will not happen. It takes a little time. That is why it is called improved maneuverability. The acceleration of engines in the medium speed engine, which are using pulse turbocharging, is definitely far superior. Next is staff loading during standby is reduced. So, okay, in the two-stroke engine, when we are maneuvering or during standby, standby is, during maneuvering is also standby. When the ship is going to leave, that time also you're on standby. When you're going through a canal, that time also engineers are on standby. That means you are alert, not the engineers who are on duty, even the engineers who are off duty. They also have to be on alert during standby periods. So if at all, in the two-stroke engine, you had to call extra engineers. Why? Because there is so often start, stop, start, stop. The air compressors are continuously running to fill up your air bottle. So you will need one engineer to continuously monitor the condition of the air compressor, because sometimes the movements are so many that the air compressors cannot cope up. You need to run both the air compressors to fill up that air bottle. In the case of a medium speed engine, this problem does not arise, because once you have started the engine, it keeps running. You don't need to stop it. The only place where the air consumption will be, it will be for engaging and disengaging the clutch. Mrityunjay has got a question. Sir, clutch assembly is present in all type of engines like low speed engine and high speed engine. No, 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 no. No. In low speed engine, there is no clutch. All this time, my whole effort is wasted. Two-stroke large bore engines do not have a clutch mechanism. they have a direct drive to the propeller. All right. High-speed engines are not used for propulsion. They are used for your auxiliary emergency generators on your small boats, on patrol boats, speed boats. They are high-speed engines. Otherwise, we use only medium-speed engine or low-speed engine on board cargo ships. All right. So clutch system is there when the medium speed engine is being used as a propulsion unit. A medium speed engine can also be used as an auxiliary engine to generate electricity. But there you do not have any clutch mechanism. You have the engine directly coupled to an alternator. So that is for producing electricity and only electricity. All right. And those engines, when it starts, it is under no load because they are not getting enough power from the alternator. Alternator will not provide any resistance at the start of the engine. So you don't need any clutch. But in your main engine, which is running your propeller, you need a clutch mechanism. And this clutch mechanism is only for your medium speed engine, not for your two-stroke engine. Mrityunjay, are you clear with this or not?
Yes, sir.
Mrityunjay?
Yes, sir.
Okay, be very clear. These are the places you will get caught during your interviews with shipping companies. They will ask you, medium speed engine, you know what is a medium speed engine? How is it used on board the ship? You tell them a medium speed engine will have a clutch if it is used for propulsion, but it will have no clutch if it is used for electricity generation because you don't have any resistance at the time of starting. You can run it idle. You don't need to put the alternator on load, and then you can check the engine is all right or not. There's no problem. But for main engine, the clutch will be there and ability to disconnect and connect. For a two-stroke large bore engine, there is no clutch. It is directly driving the propeller. Okay. So staff load during standby is reduced. That means you don't need extra engineers when you're using a medium speed engine because your engine is continuously running. You don't need extra people to look after the compressor. You don't need extra people to look at other parts of the engine also. All right. Good that you ask questions. Mrityunjay, if you have any more questions, definitely you must ask. But keep your concepts absolutely clear. Okay, next. Engines being smaller, two engines may be deployed. This gives safety in number. One may be serviced while the other keeps the ship moving. This reduces off-hire losses. Okay. Now, all this time we were talking about comparison of engines. A two-stroke engine is a big, tall, huge engine. A medium speed engine can be a very small engine, but it can give much more power to weight ratio. So if you're going to use a small engine, why not use two engines? Because the space is available. And if you have two engines, the advantage is if out at sea a breakdown takes place which you are unable to repair, you still have a second engine which can keep the ship moving and bring it to shore, albeit at a reduced speed, but it will not be stranded out at sea. If you have a single engine and something breaks very severely, which the ship's engineers cannot repair, then that ship has to be towed. And if it has to be towed from middle of Atlantic to shore, you might as well sell the ship. The cost of towing the ship will be more than the ship. That is the way it is. Moment you're in trouble, there are people who are out to extract the benefit out of you. First, they will squeeze you. They will want their pound of flesh. So this is the case in all parts of the world. So do not be in trouble on board the ship. If you're in trouble, people will help you, but at a very, very high cost. So for this, there are several companies who have salvage tugs. Those tugs are huge, as big as a cargo ship. And they are very, very powerful. They can pull any ship, pull anywhere for any length of time. And two of those ships are posted in Rotterdam, two in Cape Town, two in Singapore, two in Yokohama, two in Panama Canal. About 8 or 10 of these points are there all around the world. And they keep waiting for some ship to give a SOS, and then they move. They are the called salvage tugs. They will go and rescue a ship, but at a very high price. They get one job in a year, and it is sufficient for them to pay for all their expenses for the rest of the year. It's like that. So shipping companies are also cautious. They don't want to get into these situations. They go into medium speed engine, and instead of having one medium speed engine, they will have two medium speed engines, one beside the other. So if one fails, the ship is still not incapacitated. It can still move. So that gives safety in number, right? Even if you're having a breakdown on the ship while the ship is moving, you can repair it, while the other one will keep the propeller turning. So the charterer who pays you money for keeping the ship moving, he cannot stop paying you. But if your engine stops middle of the sea, for that period of time, he is not going to pay you. So the ship owner loses money. Get it? So that is called, this reduces off hire losses. That means moment your ship stops, you're off hire. You're no longer hired. For the duration that you're off hire, you're not going to get payment. It's a tough world. So everything has its price and everything is very, very professional. Number 9, spare parts of medium speed engines are easier to store, to handle, to transport, and they definitely cost much less than the two-stroke engine spare parts. You see the piston of a two-stroke engine made of cast steel, so heavy it is. And if you're in Mumbai and you want a spare piston, you have to order it from Germany. And the cost of transportation of that piston will be 5 times the cost of that piston. Whereas in a medium speed engine, you have an aluminum alloy piston. To have it transported from Germany will cost maybe as much as the piston itself, because it's very light, it is very small, the volume is small, the weight is small, so the transportation cost will be also small. And also the purchase price of the spare part will be small. So you see the advantage of having a medium speed engine for your propulsion unit. Big, big advantage. All right. By now, all of you must be thinking, then why the dickens do we have a two-stroke engine? It is such a behemoth for which we have to have so much of problem. Wait till you hear the disadvantages of medium speed engines and you will switch back to two-stroke engines. Give me a moment, please. So everything seems hunky-dory about your medium speed engines, and you will start wondering, why hasn't it always been used as a propulsion engine? Why is it that the two-stroke engines still having? All right, you will see. So right now we are only looking at the good things, the good news about medium speed engine. Soon we'll come into the bad news also. Okay. Okay, no more questions as I see in the chat column. Spare parts are easier to handle, and definitely in the course of its life, engine will require spare parts. You will have to keep buying these spare parts. Okay. Number 10, it gives 30% space saving and 300% weight saving. Just imagine how advantageous it is. Such a small thing, and it gives so much of space, so much of gain in carrying more cargo. So the ship owner should be very, very happy with these engines. They can give so much of possibility. It is, as a thumb rule, it it takes up 35 kg to deliver 1 horsepower in a two-stroke engine. All right. Whereas the mass of a medium speed engine amounts to 12 kg to deliver 1 horsepower of an engine. So almost 1/3 is the mass, or 3 times more is the weight saving that is there in a medium speed engine. Now these bits or nuggets of information should remain at your fingertips. So whenever you're discussing engines, mainly medium speed engines or two-stroke engines, you can be able to discuss. And in your discussion, you must inject some numerical data. This is one of the numerical data that you can inject. That for a two-stroke large bore engine, for 1 horsepower, the engine has to weigh about 35 kg. For a similar 1 horsepower available from a medium speed engine, The mass is only 12 kg. So 3 times the mass is required in the case of a two-stroke engine. So everybody say, God help us. The ship must be heavy on its own engines only. Where's the scope to carry cargo? Now let's see. Disadvantage. Now the bad news about medium speed engine. You have to take the good and the bad together. So first one is high lube oil consumption. Lubricating oil is the costliest oil on board the ship. So it is a perennial expenditure for the ship owner. And it is an increased perennial expense to the ship owner. So his bottom line margin will decrease gradually. What is the consumption? Usually 1.2 grams per brake horsepower per hour in the case of your four-stroke engine, as against 0.7 grams per brake horsepower per hour in two-stroke engines. The more modern two-stroke engines will have 0.5 grams per brake horsepower per engine, less than half of what a two-stroke or four-stroke engine consumes. Why is the lube oil consumption so high? Well, one thing is, after a stipulated running period, the oil in the medium speed or four-stroke engine has to be changed. There's no choice. You have to change it. Why? Because the crankcase space is open to the piston blow past possibility. So the oil is bound to get contaminated over a period of time. In the case of a two-stroke engine, you have a diaphragm and a piston rod stuffing box. So this prevents any blow past reaching your crankcase. So the oil is very well protected. So it remains very clean. Over and above that, you have that oil in the two-stroke engine continuously serviced by the kidneys of the engine, which is the purifier. You cannot afford to do that in your four-stroke engine because the purifier will not remove the acidic products which have come into the oil. It may remove some of the solid, and on board the ship, we don't run the purifier continuously with the auxiliary engine. Why? Why don't we run like we do on the main engine? Here. In the auxiliary engine, the oil sump is located just below the engine itself. Whereas in the two-stroke engine, the oil sump exists, but the oil goes into a separate oil tank. And this tank has got 20,000 liters of oil, lot of oil. In the case of an auxiliary engine, it will have at the most 300 to 500 liters. And if you happen to start your purifier, and if that purifier overflows, within 5 minutes, all the oil will have gone, the engine will be very severely damaged. So we do not run the purifier continuously with auxiliary engines. We do run it for a short while when the engine is stopped, and somebody has to be there. And definitely a good amount of dirt comes out, but the acidic products within the oil will not come out. So that is why the crankcase oil has to be changed in the case of a four-stroke engine. Now, if you keep changing every 3,000 hours, the overall lube oil consumption for that engine is going to be very high. All right, and that is why it is a high lube oil consumption for main or four-stroke or medium-speed engines. Karthik, did you understand this?
Yes, sir.
Okay, good. Who else is there in the class? I only keep calling Karthik. Okay, Manohar Singh, Hari Krishna Pal. But most of the guys are sleeping. If I call, there is no response. That's the very sad part. Okay, I'll call any one of you just after this. Next question.
Hello, sir.
Yeah, what is it?
Sir, in case of two-stroke engine, purifier is not removing the acidity of the oil.
In case of two-stroke engine, it's rankling. The sound is rankling. Let me reduce the volume. I can hear it is very loud, but it is rankling in my ears. Oh my God! Where is the sound? Yeah. Just a minute, please. Oh, it is very high. Okay. Yeah, Mrityunjay, repeat your question once more, please.
Sir, in case of purifier of a main engine, It is not
Yes.
removing the acidic part of the oil.
Where is the acidic part coming in the crankcase oil of a two-stroke engine? There is no blow pass coming into the crankcase. You have a diaphragm. All right. That diaphragm and the stuffing box prevents any blow pass gases. The blow pass gases are the ones that has the sulfur dioxide. That sulfur dioxide gas is not allowed to come into the crankcase. So where is the acid? There is no acid coming in.
Yes, yes, sorry, sir.
Okay, that is the good. Never mind. Get your ideas clear. Good that you asked and got it cleared. In the four-stroke engine, the blow pass is directly into the crankcase. So the oil gets contaminated not only with combustion debris. Combustion debris means ash, then oxide, catfines, oxides of catfine, then you have carbon, and you have sulfur dioxide, sulfur trioxide, acids. Everything is blown into the crankcase. So four-stroke engine oil has to be changed after a stipulated running time. Same with your motorbikes. You must be riding motorbike, and all these. Most of the bikes are now four-stroke. Previously, we had two-stroke and four-stroke. So the two-stroke bikes were comfortable. They never used to change the oil. But the four-stroke bikes, after 1500 kilometers of running, you have to go drain that oil, put fresh oil, and again move on. So that is why the oil consumption in four-stroke engines is definitely much more. Okay. Okay. Now the question to you, Mrityunjoy, how is the cylinder lubricated in your motorbikes of two-stroke and four-stroke? You think it out and keep it with yourself, and we will proceed with the class. Now here I have three different engines, and they are each comparable to each other. I would like you to make a choice which one you would like to install for your medium speed as a medium speed engine for your shipboard. Now, suppose I give you a ship, a reefer ship, which is going to carry bananas. It is carrying bananas from Kerala to Kolkata. All right. The trip is, say, 5 days. It's not a very big reefer ship, medium sized reefer ship. So think which particular engine you will require or choose, and what are the features you will be demanding from such an engine. All right. So that do an assignments of similar nature for your own benefit. If you were a ship owner, think like that. If I am a ship owner, between the three engines, which one will I take? And what all facilities it must have, what all features it must have to make sure that your reefer cargo is reaching its destination without any fault. Right? You have to start thinking on those lines. You cannot afford to think as an engine cadet all the time. Okay. Oh, let's go through this one. There are the three engines. One is the MAN, one is the SEMT Peel Stick. Peel Stick is also a very good engine. It is originally German, but that German company shifted to France during the war and started manufacturing engines in France. So SEMT has a certain name, long name it is, and the engines they manufacture are Peel Stick, PC3, PC2, PC1. That is one company. They are comparable to Sulzer and MAN. Now here Sulzer has given its medium speed engine, MAN has given its medium speed engine. So you choose between the three which engine will be to your maximum benefit, and accordingly. All the parameters are given, including mean piston speed, compressor, specific fuel consumption, thermal efficiency, all. All right. This is the indication how difficult it is for a ship owner to pick and choose a particular engine. Now, let us go through the constructional details of an engine. The engine block is one piece. It is a completely cast unit, one block. And on that block, all the fittings are put on. Right. So the crankshaft is underslung, which means there is no bed plate required. See, on the block on the underside, you have those keeps similar to your bottom end bearing lower keep. That keep is fitted against underside of the engine, and the whole crankshaft is hung. Hung means underslung, and when the load comes, it comes on those keeps, and it is capable of taking the load, and it does not have any bed plate. So what about the sump? Okay. Now the sump is basically a tin plate, not tin, it is a mild steel plate which is bended and shaped in the form of a sump, and it is welded onto the block. So it forms your sump. Of course, there will be a drain passage also, and it will have the required pump suction run by the engine, etc., whatever it is. So these modern engines, they are monoblock engines. Apart from this, the crankshaft is made rigid with overlap to reduce stress. See, a crankshaft, if it is a straight shaft, which cannot be, it is a very rigid shaft. But if it is made with the crank throws, it becomes weaker, where torsion is concerned or bending is concerned. So now if the throw of the crankshaft is very large, it becomes still weaker. That means the crank pin, if it is far away from the journal, then that shaft has a tendency to bend at the webs. The webs will be taking a lot of stress. I had shown you a diagram earliest when we were discussing crankshaft. When the force on the crank pin comes, how the crank pin bends and it twists the crank web and it twists, bends the main journal. So all these stresses are involved in the crankshaft. And bigger the throw, more the twist will be on the crank web. And there I had shown you also how crank webs have fractured, have been damaged. Check up your old links for the classes and you will see how crankshaft breakages have taken place. Now, if the crank throw and the crank pin are made as close as possible to each other, the crankshaft has a tendency to be much more stronger. So this strength is derived from overlap. You have heard overlap in terms of inlet and outlet valves of the engine, where both the valves are open for a certain duration of time. That is called overlap of valves. Similarly, the term overlap is used here in the crankshaft if the diameter of the crank pin and the diameter of the journal have a overlap space if you look at it from the from the side. Okay, this overlap reduces stress. That means bending of the web is not there. I show you the diagram just now. Don't hassle. So some engines do have cast iron one-piece bed plate. It is not that all engines or all modern engines have underslung bed plates. Some of them have normal bed plate with the block also. So do not limit your thinking that all engines are underslung bed plates or underslung crankshafts. Some of them have crankshafts. So the choice is various. Now the cooling passages and lube oil passages are bored through the block. Now this engine block, instead of having pipelines all over, they have drilled passages through the block in various positions. And these drilled passages provide for flow of the fuel oil, the lube oil, the air, starting air, etc. So only at a terminal point you will have the pipe coming from outside and it is fixed on the engine block. The under the flange portion of that connection will be drilled passages inside the block. And from the respective units, you will have outlets which will go directly for whatever function it is required for air starting valve. So there will be no common pipe in the engine, only one drilled passage inside the engine. Same goes for lubricating oil, same goes for cooling water, everything. So that engine block provides for that facility where no pipes are required. Cylinder head is cast steel with four valves. Okay. Now, four valves, that means how many inlet, how many outlet? There will be two inlet and two outlet valves. Okay. Now, Indrajit Moitro, I have a question for you. Why will an engine have four valves when two valves are quite satisfactory? One was an inlet valve, one was an outlet valve. Why will you have four valves, which two are inlet valves and two are exhaust valves? Maitro,
Yes, sir.
why? Answer my question. See, you're not paying attention. It's quite evident you're not paying attention. So what we'll do, we'll skip. Manohar Singh, Manohar Singh,
Yes, sir.
why will we have four valves instead of two valves? Give your own ideas, don't worry.
Sir, if we will use four valves instead of two valves, then we can reduce the weight and also increase the efficiency because air intake will be more, breathing will be more for the engine.
Absolutely right. That's a very good answer. The breathing characteristics of the engine will improve if you have larger opening for gas transmission. That means air comes in quickly, fills up enough, and again goes out also quickly. So how well you breathe will decide how well you can run a 100 meters dash. And how poorly you breathe will also indicate how poorly you run the dash. Correct? That's right, Manohar. Okay, let's move on. Where were we? Cylinder head of the cast steel with four valves. Pulse turbocharging is commonly used. Yes, medium speed engines will always have pulse turbocharging. I told you why. They gave immediate acceleration. Now let's have a look at the crankshaft which we were talking about. Now here is the crankshaft of a medium speed engine. In a two-stroke engine, the crank webs will be much longer and the crank pins will be also down here somewhere. So the crank throw means the distance from the center point of the journal to the center point of the crank pin. If this distance is large, it means the crank throw is large. Right. Now, in the case of a medium speed engine, the crank throw is made small intentionally to ensure that the crankshaft has some rigidity. Now, over here, if you see and look at it from the side, you will see that the cross section of the crank pin and the cross section of the main journal. Sorry, this is the crank pin and this is the main journal. They have a certain overlap. This overlap provides some amount of rigidity to the crankshaft. It is much more stronger. There will be no crankweb deflections so easily. So it will stay in a much better shape and have more amount of reliability. Okay. The figure shows drilled bores for lube oil to connecting rod. Now, the lubricating oil which is fed to the main bearing, this is the one where the main bearings come in. It is fed in and the shaft itself has got a drilled passage. So the drilled passage goes through the crankshaft and it comes out from the crank pin. Similarly, a drilled passage from this bearing comes out from this connecting rod bearing. Once it comes out from here, it can not only lubricate the bottom end bearing, it allows for the oil to go up to the connecting rod and lubricate the gudgeon pin. That gudgeon pin bronze bush also needs lubrication. So it is lubricated there. Apart from this, some of these engines, they also have a path of oil which flows directly to the oil scraper rings. So that oil scraper ring groove, it has got holes. And this oil through the boss of the piston allows the oil to go into the scraper ring. So it comes out from the scraper rings from the midsection. And this oil helps for cylinder lubrication. And the scraper ring that is fitted helps to scrape off the excess oil because you don't need so much of oil for cylinder lubrication. Whatever oil comes onto the surface is scraped off by means of the scraper rings. Some call has come out. Abir Day. Oh, NYK. Just a minute. Just a minute, boys. This is a call from NYK Ship Management. What do you want now? Excuse me, guys. This is important call. Definitely. Okay, 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 definitely. Okay. Yes, that has to be maintained. That can be up. তারপরে ওটাকে এন্ট্রি করতে পারে anybody. Okay, okay, okay. That's a good idea. हाँ. Hmm. हाँ. Oh, okay, okay. हाँ. উফ মাই গড, আচ্ছা আচ্ছা, তারপরে ওটা কুরিয়ারে পাঠানো হয়েছে। উফ, ও হ্যাঁ, তাহলে নাথিং ইজ মিসড আউট অ্যাকচুয়ালি, এভরিথিং ক্যান বি রিফিলড ইন। হ্যাঁ, yes, only the transferring the information to the other one. Okay, okay. হুম. ওকে, 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 আমরা তাই করবো এখানে, just soon as we get hold of it we'll send it by courier. ঠিক আছে। ওকে, ওকে, ডেফিনেটলি, ডেফিনেটলি, ওকে। হ্যাঁ, আমরা সব ঠিক আছি। উই আর ওয়েটিং ফর দিস 15th of June আবার শুরু করা হোক, and we are trying to get our boys also ওই ট্রেনিং যা দরকার ছিল ওটা। হ্যাঁ, আমার ডাবল ডোজ হয়ে গেছে। অল অফ আস আর ফিনিশ ডাবল ডোজ। কোভিশিল্ড আমি ছেলেদেরকে বলে রেখেছি যে দে মাস্ট নট টেক আ ভ্যাকসিন হুইচ ইজ নট রেকগনাইজড বাই ওয়ার্ল্ড হেলথ অর্গানাইজেশন, তা নাহলে ওদের বাইরে গেলে আবার ঝামেলা হবে। হ্যাঁ, which one? Oh, okay. So they're getting it in USA. Oh, আচ্ছা, আর যারা এখান থেকে যাচ্ছে from India, when they're going, what vaccine are you giving them? Oh, but suppose he has taken Covaxin, which is not recognized by World Health Organization. Okay, okay. আমি এই দিক থেকে আমাদের ছেলেকে একটু বলে রাখছি that don't go for a vaccine which is not recognized. It may have issues later because very soon you will be requiring a passport vaccine. And that passport vaccine will have to be carried with you along with your normal passport. Yes, by August they are saying. August এর মধ্যে হয়ে যাবে। Complete হয়নি, right, right. Yes, then it's okay. Yes, yes. আচ্ছা আচ্ছা, হ্যাঁ. Sputnik was not recognized. শুধু Sinovac and Sinopharm have been recognized. ওগুলো তো আছে, ওগুলো ঠিক আছে। আচ্ছা, one time, yes. Okay, okay. Okay, very good, very good. Oh, very good. Yes, absolutely. Absolutely. Yes, definitely. Okay, okay. ठीक है. Yes, absolutely. अच्छा. हाँ. हाँ. Yes, we'll give you the best advice. Okay, 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 okay. Thank you very much. No, no, no problem. I'll continue. No problem. Okay, okay, okay. Have a nice day. See, guys, that was from Mr. Abir J from NYK Ship Management, and they are having issues with one boy, Abhay Kumar. They need his tar book. Now, his tar book has to be got from our office and sent to Mumbai by courier. But in our office, it's closed. So now nobody is coming to the office. Now, how do we get that tar book out? Only after 15th. And on the 17th, he's supposed to join ship. So the decision is that he can join ship without the tar book, and they'll have to courier the tar book to Singapore, wherever the ship is going. So now these issues have come up, and hopefully we expect that there will be no more lockdown after 15th, and we shall be able to go to office to perform these actions. So I have written to the head of office, but they are not. Nobody can do anything. If it is a lockdown, it's a lockdown. First priority is fulfilling requirements of lockdown. Everybody is in trouble. What to do? Okay, let's get back to our subject. So this is your crankshaft. Sir, how the lube oil is supplied to the bore of the rotating crankshaft? Okay, good question. The lubricating oil comes from the sump. All right. The sump takes the oil, the pump takes the oil from the sump and it passes through a manifold, a common manifold. All right. From this manifold, manifold means pipe, a big pipe. From this pipe, individual pipes keep coming out from each unit. All right. And these pipes ultimately go and are fitted on the main bearing cap. So the main bearing gets the oil first. That is the crankshaft bearing. It gets the oil. Once it comes to the main bearing, this is where the oil gets. From there, it goes through these bores and it comes to the crank pin bearing. That is the bottom end bearing. Once it comes to this bearing, the oil further proceeds up through the connecting rod, right up through the gudgeon pin. Now, where is the diagram? I gave it in your 5th semester, if you remember, lubricating oil. So that is how the lubricating system, where is that? I have to go back now. I don't want to change this PowerPoint. Okay. So, Kartavya Singh,
Yes, sir.
it comes from the main manifold, and that manifold is pumped with oil by the engine-driven pump in the case of a medium-speed engine. And that oil comes from the manifold in separate pipes to each of the main bearing units. This is one unit. This is another unit. Similarly, every unit will have a main bearing. The crankshaft has several main bearings. So the oil comes to the main bearing. It goes into the main bearing, lubricates the main bearing. The excess oil further moves through the bore of the journal. This is the bore. That means the hole in the journal allows the oil to pass through and come to the crank pin bearing. From here, it comes, lubricates the crank pin bearing and further moves up through the connecting rod to the gudgeon pin bearing. Have you understood?
Yes, sir. Yes, sir.
Okay, let's move on. This is the one. Next is this. Okay. Now, Further, we are going to discuss about the bearings of the crankshaft. We are going to discuss about the modern bearings. I am leaving out the old casting bearings that were used earlier. They are of no consequence now, and you are unlikely to see them on board also. So the thin shell bearings is the more common type of bearing that is used for your main bearing. It is used for your bottom end bearing. It is also used for your crosshead bearings in two-stroke engines. But in four-stroke medium-speed engine, the gudgeon pin bearing is still a bush bearing. In the gudgeon pin, you do not use thin shell bearing. You only use a bronze bush bearing. All right. So main and bottom end bearings are of the thin shell types. We'll show you the diagram shortly. These are white metal lined. What is white metal? White metal is a combination of various elements like lead, tin, copper, antimony, and there are other materials also. Sometimes chromium is used, sometimes molybdenum is used, sometimes aluminium is used. So there are other metals also in very small proportions. But the main components of white metal are either lead based or tin based. Right? So you will have lead, copper, antimony. In the tin based, you will have tin, copper, antimony. These are the basics. Now the permutation and combination of percentages of lead and copper and tin are thousands. So you have different thin shell bearings with different strengths of the white metal, different properties of that metal. So these are decided by the engine manufacturer when he calculates the values of the load, the speed of the engine, the area of the bearing. All these are calculated to decide what strength of material he will use as the white metal. So this white metal can be of various strengths, that means hardness. Some of them may be soft, some of them may be harder. So these are chosen based on the requirements for that particular bearing. And the engine designer is the one who will recommend the particular type of bearing shell that is to be used. Okay. The gudgeon pin bearing is a grooved lead bronze bush. In my earlier classes, I had told you that the gudgeon pin has a bronze bush. Well, this bronze bush is not pure bronze bush. It has some amount of lead in it. Lead provides for some softness within the metal, and it helps for better friction reduction. So that is why the bush which is used for the gudgeon pin is a lead bronze bush. This bush also has grooves on the internal surfaces. This grooves helps in retaining some of the oil when the gudgeon pin is moving or when the bush is moving around the gudgeon pin. Now, sir, in the figure, the oil passage has been drilled across diagonally, but it should be along neutral axis. Is this not the case? Karthik, you're looking at this view, the frontal view. Now, if you look at the end view, okay, let's go back to that view. I should be able to draw. Oh, wait a minute, where is the diagram? Yeah. Now, this is frontal view, all right? The view of this is coming from the main bearing up to the center part of the thing. From here, it will go at a particular angle which is at the neutral axis. This is the crank pin, all right? Now, I have shown you here because I cannot show you any other way. From it is going through the center. That means the central portion of the shafts. From here, it has to emerge to the surface, and it will emerge at that particular angle where it is on the neutral axis. All right. You're looking at it from one side, and I have to show you this hole over here. So right now, what you can see, the hole should be right over here. Okay. But if you actually turn this and make it, say, at this point, okay. So where is the neutral axis? It will be right on this surface. When you put it on this side, it will be here. It is almost actually at neutral axis right now because it is shown at BDC. Okay. So it is on the side. So when the pressure is there, load is there, the tensile stress will be at the bottom and the compressive stress will be on the top. So the neutral axis will be around here only. What we are seeing is almost correct. Maybe a few angle of degrees here and there. It may be slightly at an angle here or an angle here, but it will definitely be on this side. So imagine this crankshaft in this angle. So when the force is coming here, the tension will be at the bottom and the compression will be on the top. So the thing will be exactly at this point here. So this is at neutral axis if you see it at the bottom when it is rotated in this direction. That is why I have not shown you the dotted line over here. The dotted line is here. This is how it is seen as if what you're seeing. Yes, you're right. It should be at the neutral axis. Otherwise, your crank pin will start shearing off. Okay, so let's move on. Where were we? Here. The bearing shells have an interference fit with nip and crush. In other words, the shell diameters are such that the overall circumference is little more than the keep of the connecting rod and the bottom keep. So that when you put the two together with the shell, there will be a gap on the sides. This gap is removed by tightening the bottom end bearing bolts and closing that gap. This gap is called the crush. No, here it is. Let us see where it is. Yeah. Now you see, the shell is a little bigger diameter or a circumference as compared to the keep of the house. So it is increased by this much. This is a few hundredths of a millimeter. All right. So when this shell is put with another shell on top, and then the connecting rod and the bottom keep are put over that, there will be a gap here. So this gap is barely a few hundredths of a millimeter. So when you tighten these bolts, what happens? It puts a pressure on the circumferential surface of both the shells. So both the shells are pushed together and some amount of deformation takes place at this end, but within the elastic limits. It will not cause any distortion or damage to the bearing, but it will exert enormous pressure. If it exerts enormous pressure here, it will mean that the pressure is again reflected at the circumferential surface over here. So this helps in increasing the friction between the surface of the shell and that of the keep, so that the shell, once it is fitted, it will not rotate inside the bearing easily. And that is the basic intention, to fix that shell tight inside the keep so that it does not rotate. Why? Why should it not rotate? Because you see the thin shell at the top will have a hole over here. And if that hole is misaligned with the connecting rod, then the oil will not reach the gudgeon pin. If the shell rotates, what damage can take place? It will not allow the lube oil to pass through and reach the gudgeon pin. I hope you're able to understand, because the hole in the shell is at a fixed point, and that hole must match with the hole in the connecting rod. And if the two shift, or if the shell shifts away, then it will be a blind hole. It will not allow the oil to pass through. So that is why it is very crucial to have the shell tightly fitted inside the bearing keep. Okay. Bearing shells have an interference fit with nip or crush. Both mean the same thing. This is required to grip the shells of the connecting rod. Axial location of the crankshaft is provided by special bearing. That means the whole crankshaft is capable of moving in the axial direction marginally. So it has to be located or fixed in place. In the case of a two-stroke engine, the thrust bearing, which is fitted to the propeller shaft, which is fitted to the crankshaft, locks the entire shafting system in one place. In the case of a medium engine, there is no scope of any thrust bearing acting on the crankshaft. So the crankshaft must be located actually in a particular position. And this is done by a special bearing, which is on the last bearing just before the shaft moves out to the flywheel. Okay. Only one special locating bearing is allowed to allow for thermal expansion. Now the whole crankshaft, you can't grip it in two places because the shaft has to expand, contract. So you can only hold it in one place. So you hold it in one place and allow the shaft to expand as per temperature changes. So here is the diagram to show you the locating bearing of the crankshaft. You see, this is the last transverse girder inside the bed plate, or it is the last bearing, main bearing, which is supporting the crankshaft. This has a special shell which has got a surface axially to be taking the axial force of the crankshaft. This crankshaft, you see, this is the web, this is the crank pin. On the web, you have a protruding part which makes contact with the white metal part of the thin shell bearing on this side. On the other side, you have a collar. You have a collar on the shaft, and that collar takes support on that bearing. So now this crankshaft cannot move axially either to the left or to the right. So the crankshaft is located only in one place in the axial direction. The bearing is got a coating of white metal, so the surface can comfortably run on it. And the load is very little. There is hardly any load. It is only keeping the crankshaft in position. It does not allow it to float away. Okay. Karthik, have you understood this diagram?
Yes, sir. Understood.
Okay, good. Next, now we go to the pistons. The pistons in medium speed engine are generally of aluminium alloy. What is the advantage? Aluminium alloy is not aluminium. Aluminium alloy is a mixture with other metals also. Keep that in mind. What is the advantage? Low density, hence reduced weight and inertia stress. If the mass of the piston is less, it means the acceleration and deceleration forces that arise with piston movement are also reduced. So the bearings are subject to lesser stress. And this stress is arising because of the inertia that comes about with a bigger mass of piston. All right. In the case of a two-stroke engine, the inertia forces are not so high because the speed of the engine in the two-stroke engine is much less. So mass into acceleration, mass is the mass of the piston is multiplied with the acceleration. That piston speed is moving fast. It has to stop at TDC, stop at BDC. So you have to accelerate and decelerate. This causes enormous forces on the bearings. It is not only the gas forces that are acting on the bearing. The accelerating and decelerating forces on the bearings are also very high. Apart from this, aluminum alloy pistons also give high thermal conductivity. Aluminum is definitely a better conductor than steel. So the dissipation of heat that accumulates in the piston is also quickly transferred. So there is no thermal stress of a large scale involved with the piston. All right. Next is simple fabrication techniques. An aluminum alloy piston, particularly when the size is small, is much easier to manufacture, much easier to have the grooves machined out because it's softer. Whereas in the two-stroke engine where you have a cast steel piston crown, handling that piston crown is a difficult task by itself. Over and above that, you need to have the grooves machined. So it's a very difficult process for a two-stroke piston which has got a cast steel piston. In the case of aluminum alloy piston, it is definitely much easier to machine out the groove, and thereafter if the piston is a reject after use, long use, if it is rejected, it can go for recycling and manufacture other aluminum alloy components. Aluminum alloy components are many. Sometimes they are used for connecting rods, parts also. Various parts of engines are now aluminum alloy. They have high reliability and requisite strength. They do not have extreme strength, but they have requisite strength, which means the strength that is required of them to take up. And what is this material of aluminum alloy? It is 12% silicon 1% of copper, nickel, and manganese, not magnesium. Magnesium is Mg and Mn is manganese. So don't make a mistake here. So you have 85% aluminium, 12% silicon, 1% of copper, 1% of nickel, and 1% of manganese. Okay, any more questions? So this is the bottommost part. Okay, so let's see how many are paying attention. Madhav Kumar Jha, are you listening?
Yes, sir.
Okay, what is the constituents of aluminium alloy? Just now I told you. See, you're not paying attention. It is 12% silicon and 1% of nickel, 1% of copper, and 1% of manganese. 85% is pure aluminium. You're not paying attention, Madhav. There seems to be only 2 or 3 boys who are paying attention. All right, ultimately, it is your goose. You cook it, you have to eat it. I can put in my best, my effort, but it is for you to ultimately absorb the information and learn the subject. Okay. We are almost finished our time and we have not yet finished. Anyway, this is your constructional detail of a medium speed engine piston assembly. You see there are 2 compression rings, 1 scraper ring. This scraper ring is also called oil control ring. Why? It controls the quantity of oil that is coming on the cylinder. If there is excessive, it has a tendency to scrape off the excess oil. The gudgeon pin in this case is called a wrist pin. Actually, wrist pin is a term used for very small engine. Possibly this is a reasonably small engine. For a little bigger medium speed engine, you will call it a gudgeon pin. And this gudgeon pin is fitted inside to hold the piston and the connecting rod together. Apart from that, the gudgeon pin has to be locked in position by means of 2 circlips. Circlips over here are being called snap ring. They are circular rings which are compressed, fitted in and allowed to expand. So there are grooves inside the place where the gudgeon pin is to allow for the snap ring to snap into position. And that prevents the gudgeon pin from shifting out axially and striking the cylinder liner when it is working. The connecting rod is a cast steel component. In some engines, it may be aluminium also. You have the bearings which are thin shell bearings, and these are the bottom end bearing bolts which are required to be changed after a stipulated running hour, irrespective of how good the condition is. That stipulated running period can be anything between 15,000, 20,000, 22,000. It is all up to the manufacturer. So this is your piston assembly. Next is, these are the means of which the 4-stroke piston can be cooled. So the first diagram shows a gallery system. The gallery system is where a copper pipe in the form of a coil is cast in with the aluminium crown. So when they are casting the aluminium crown, they insert 1 copper coil inside. So the copper coil is actually a copper pipe. This copper pipe helps the oil to circulate inside the crown before it drops off. So that oil which is circulated through the copper coil extracts the heat from the piston crown and delivers it back into the lubricating oil which drops into the crankcase. Now let's have a look at how it happens. The oil which I showed you in the earlier diagram that is coming to the crank pin, from the crank pin it goes into the connecting rod, goes to the connecting rod, goes round your gudgeon pin and then into the boss. Boss is the aluminium part of the piston which is loading onto the sides of the gudgeon pin. From there you see the dotted line, it goes into this coil over here. And once it enters the coil, it goes circulating inside the coil and then it comes to the topmost part and of the coil and then it drops into the space where the gudgeon pin is. It simply falls into the crankcase from here. So this is the means of cooling the piston crown. So it is called a gallery system. A second system has got a nozzle on top of a connecting rod, so that the oil which comes through the connecting rod after it lubricates the gudgeon pin allows for a fountain of oil to to splash on the underside of the piston. You see, the crown is very hot because the combustion takes place on top. So the heat is transmitted to the underside of the piston, which is again extracted by splashing oil on the underside. So this is one means of cooling the piston. A third one has a nozzle fitted onto the engine block, and this block is stationary, but the piston is reciprocating up and down from TDC to BDC, and the underside is so exposed that a jet of oil always allows the oil to run on the surface on the underside. Okay, so this is another means of cooling. A fourth one is called a chamber. So second one is called a splash cooling. The fourth one has got a chamber. That means there is a pocket inside the piston, and the oil which comes from the connecting rod ultimately fills up this space here. And once the filling is done, there is an outlet passage located from the top of that chamber, which allows the oil to drop out. Now, when the piston is moving, it provides a cocktail taker cooling arrangement. In other words, the whole oil mass is moved or splashed inside the crown, and this splashing makes the oil contact the underside of the piston crown and helps to cool the whole piston. If you have seen on the roadside where they sell lassi, he gives you a glass with ice and lassi and everything in it, and he puts another glass on top, and he shakes up the whole mass inside, and then gives you the lower glass. The upper glass has already become cool because the ice and the water has made contact with the surface on top, and that contact was made when he was moving his hands. So this movement of his hand over here is interpreted as the movement of the piston, and thereby which causes the oil to splash inside and cool this underside surface of the piston. So these are the four different means of cooling the piston. Okay. Next, what we have is used thin shell bearings. Now, these thin shell bearings can use bimetal or trimetal. This part is understandable because it's a little extended. Remember, it has a white metal, it has a copper inlay, and it has a steel back. The steel back is what gives it the strength. White metal does not have the strength. So it can have a flash layer. Flash layer is just 1 micron. The topmost layer with the thickness of 1 micron made of tin and lead and used to protect the bearing from corrosion and dust when not in use. That means when the engine is new and the bearings are new and it has not been run, this flashes off when the bearings is in running in period. Running in period is the period during which everything settles down. Overlay. The second layer is made up of white metal, tin, antimony, and copper, which is the main component in this type of bearing, and its thickness varies. Depends on the load that the bearing is going to support. Interlay. It is the third layer used as an anti-corrosive layer or overlay. It is 5 microns thick. It is like a connector, adhesive. The lining. It is the lining layer between the interlay and the steel back with a thickness of 1 millimeter made up of lead and brome. And last you have is a steel back part used for shape and support. You see, there are various types of thin shell bearings, but we will stick to the basics. And the basic is a white metal layer, a copper layer, and the steel back. The copper layer has the function of bonding the white metal and the steel. And in their research, they have found various means of having this bonding strength and increased to the maximum. See, just having white metal on the surface is not enough. That white metal has to stay there. If the white metal gets moved out, then what is the big idea? So you need a very special arrangement where the white metal can bond with the steel and not shift when the forces are applied. And this seating or bonding between the steel and the white metal, copper is the best. Okay, and that is called copper alloy. In the extreme right, what you see is an aluminium layer aluminum bearing alloy, not pure aluminum. Below this, you have pure aluminum because pure aluminum has got a better bonding strength between aluminum alloy and steel. So likewise, in a different type of a bearing, this is aluminum bearing. This one is a white bearing, bearing. So you have a overlay, then you have a nickel barrier, then you have a copper lay, and then you have the steel back. So these are the different means of having a thin shell bearing. Remember, the thickness of the thin shell bearing amounts to 2% to 2.5% of the journal diameter. This is another thumb point rule which you have to keep in mind. The bearing shell thickness is 2 to 2.5% of the diameter of the journal that it is supporting. Okay, so today we'll call it a day, and remember we have reached page 19. Karthik, please remember that we are on page 19. We have to go faster
Yes,
than
sir.
this. We have to go much faster than this. And I want the attendance. There's 38 here. There should have been 40. This is section C. So there should have been 40. Let me check who is here and who is not here. Okay, you'll have to wait till I finish taking the attendance as I can. Divakar Tripathi 8078798081. 82 is missing. This is section C. So 82 is missing. 8082. 83, 84, 85, 86, 87, 88. 8990. Now, Jayant Kumar Gorai, are you 89 or 90? No sound. Jayant Kumar Gorai.
Sir, 8-9 is withdrawn.
Oh,
So
89.
90, sir.
89.
So Jayant Kumar Gura is 90.
90. 89 withdrawn. 8089 withdrawn. Okay. 9192. Who is 92? Missing. 9394. Karutharan Ashwin, you're 95.
Yes, sir, I'm 95.
Okay, 96, 97, 98, 99, 801. Kundan Kumar Sharma, you're 8. 102.
Yes, sir.
Right.
102, sir.
Okay. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is missing. 8111. Okay. 8111, 2, 12, 13, 14, 15, 16, 17. The last man is Neha, last girl is Neha Sasti, 8117. All right. So let me mention the absentees and withdrawn. 8082, 8089, 8092, and 8111. Okay. So that will be all for today. And I don't know if I can finish your syllabus also. You have to go faster than this. Okay. Be ready. There'll be multi-choice questions galore. So practice multi-choice questions. And what bits of information I'm giving you? Absorb. Because it will be like that. The percentage of silicon in thin shell in alloy steel in piston crown is 10%, 12%, 14%, 16%. Now you have to tick off which one is there. It is going to be like that. So be very careful with small bits of or nuggets of information. They should be at your fingertips. There's no descriptive, only raw data. So bye-bye for now. We'll take care in the next class.